Good morning. My name is Dr. Gordon MacLeod, and I've been asked to present the business of astronomy, maximizing economic impact on behalf of myself and my associate, Dr. Noorali Jiwaji. Both of us are associated with the Open University of Tanzania, and myself, I also am involved in the JIRA Foundation, an organization designed to help fledgling observatories such as the Kilimanjaro Telescope Project. Today we will talk about the economics of astronomy.
The JIRA Foundation presents this series called Navigating Research.
Let me present just briefly a simple economic model called PHET Theory. It's something we devised while I was working at the Department of Science and Technology in South Africa. And really there are four main factors, four main contributors to the return on investment of a science project. So the government, which sits at the table here, the science project, will use tax-funded monies, and from it they will extract economic benefit from things such as prestige, the science, written by the scientists, human capital development, students, educated by teachers, professors, etc., economic activity, driven by entrepreneurs, and that includes things such as business development, things like that. And finally, tech transfer or technology development. And that's driven by engineers. So really you have these four areas: prestige, human capital development, economic activity, and tech transfer. I mean, the top two are pretty clear. If the project is prestigious, if it draws attention from the entire globe, it'll actually spot a very positive light on Tanzania, or shine a very positive light on Tanzania, and that will lead to the opportunity to attract young researchers and senior researchers to universities in Tanzania, thus helping the economy of Tanzania. Human capital development goes without saying, really. Here we're talking about producing students in STEM, so engineers, scientists, technicians, millwrights, etc., people that work on various aspects of the telescope. And the more people that touch the telescope from this area, the more the impact that the science project will have on the economy of Tanzania. I'm going to skip the third one for a second and go to technology transfer. Hopefully we'll be doing technology development in the country, because that really does maximize this, when you have companies developing the technology that'll be used in the science project. But even without that, every telescope that's built is basically cutting-edge engineering. It's really engineering on steroids. So everything about a science project of this nature, astronomy, is generally implying you're using cutting-edge technologies. And therefore, you're giving engineers a chance to work on new technologies, which they can in turn move into the industries of Tanzania itself. So you want to create positions where people can come and work and touch the telescope, work on the technology, and then go away to your telecoms companies, or become a programmer at universities, or work on equipment, signal processing equipment at hospitals or radar stations, etc. And that's how you optimize technology transfer. But I want to talk about economic activity, and this is really the odd man out in science. And what I mean by that is scientists typically do not talk about the economic activity around astronomy. They don't worry about it. It's not their bread and butter. They want to look at the science. The engineers want to play with the technology. The educators want to help students learn and graduate. But what we want to do also is we want to improve or maximize the economic return of any kind of investment in science. So whether the money's coming from overseas or locally, you always want to optimize this factor right here. So you do that by astrotourism as a simple example, and not even directly related to going to see the telescope. Astrotourism could mean selling t-shirts, or selling pretty pictures in newspapers or online services, news services. Or it could be restaurants that cater to people that want to come and go to the observatory or work at the observatory. So those are sort of activities in and around astronomy that are not related to the actual operations of the telescope that add value. Other things, of course, and I'll talk about them in more detail, there's really one very exciting aspect of Kilimanjaro Telescope project that really caters to this particular activity. So, in conclusion, PHET theory really is a simple way for the government to look at a project and optimize and maximize the economic return from a project by maximizing prestige, what the scientists are doing, the number of students who are developed, human capital development, the economic activity around the project, and also importantly, the technology being transferred into the project. So that is our simple economic model that we're going to work with for the rest of this talk. Why astronomy, you might ask? I mean, what would be the value of doing astronomy in any country that doesn't even have observatories presently built, or research facilities, or even research departments for that matter? But why astronomy? And in this case, why particularly radio astronomy, millimeter astronomy? Well, these are various comments that have been made from various groups around the world that have contributed to development of astronomy in Africa. So you see, support the development of science capacity in Africa through greater investment in infrastructure. So clearly, putting a telescope in Tanzania on Kilimanjaro represents an investment in infrastructure. It means that you can teach students in your own country. They don't have to go overseas to learn. It decreases the chances of losing students. We call it the brain drain. So we can help to reverse the brain drain by doing more prestigious projects, being involved in more, but most importantly, having the infrastructure in Tanzania. The UK, for instance, they want to help with economic development, and they see astronomy as a good driver for this. So they've been actively involved on the continent, mostly with the SKA project and its 8 African partner countries. But there's opportunities that we can expand that to more countries in the longer term. And finally, the USA has its own program where they help underrepresented individuals get access to radio astronomy. And of course, that is precisely what this is. It means that universities in Tanzania could get access to this program, which would help to expand our ability to teach and train more students, more engineers, more technicians, more scientists. Many of you might ask, why Kilimanjaro, Tanzania? Why this mountain? And the answer is really quite simple. In millimeter astronomy, and we're talking about building a millimeter telescope, that's the first thing to realize. But there's 2 issues that always plague millimeter telescopes, and they are atmosphere and precipitation. So you want to be very high and on a very dry site. And you can see here from the photograph that Kilimanjaro is very dry, and of course that's the saddle we're looking at towards Mwenzi Peak, and this site is very high, over 4,500 meters in many places, probably up to 5,000 meters in some places. So this happens to be the best site in Africa for millimeter astronomy, and the diagram below shows you the moisture content. The red is Kilimanjaro. The lower the levels, the better the site is, and you can see that only in the very driest of the winter is the Gamsberg, Namibia, even remotely similar to Kilimanjaro. But in the rainy seasons, there is no comparison. Kilimanjaro is just much better at these sites on the saddle. So the answer to the question is, for millimeter astronomy, we want high and dry. And the only site in Africa really that gives us the best conditions for millimeter astronomy is Kilimanjaro, Mount Kilimanjaro. There really are 3 issues that we face when we talk about building a millimeter telescope on Mount Kilimanjaro. And in no particular order here, I have economical, ecological, and aesthetic. The last one I want to talk about first, the aesthetics of the mountain. Really what we're talking about here, you want to maintain the pristine nature of the mountain as it is, and its beauty and majesty. And so you got to be very careful how you build things, whether it's roads, to access roads, whatever it is, okay? But also where you build things. So you would probably say, no, I'm not building at the peak, because that would destroy the beauty of the mountain right away, and it would lead to a decline in tourism. So you build on the saddle somewhere away from Uhuru Peak, perhaps at some spot where there's no line of sight. Now, ecological, of course, it's basically what I'm talking about here is, you're talking about construction. So you have to cut down trees in order to build a road. So you want to design your system that it can be built without impacting the environment any more than it absolutely has to. The roads that exist, the trails and roads that exist, we have to find ways to make them what we're going to do. Because whether I'm getting heavy equipment up there or 50,000 people are walking up those trails, either way, it's going to have an impact on the ecology, and we want to minimize that. So really, construction, we have to really seriously consider our construction. Maybe the size of the telescope has to be limited as a result of the paths that we can take. That way we don't have to cut down a single tree, for instance. And finally, it's got to be economical. So what can we do to extract some other wealth? And this is where I talked about the economic activity around the project. So in this case, we got to first off be very careful we're not affecting the tourism, the adventure tourism side of things. So that is just the way it is. The next thing is, how will you develop and grow astrotourism? So for instance, you might put an optical telescope up there with the millimeter, and you're taking photographs that you're always releasing to the public. So the public always has access to beautiful nightly views of the Tanzanian skies. Things like that, and other things, other issues of that nature. But there are other projects, there's other aspects to this project that could solve all three of these things. And I'll get to that in a moment. The key to all construction is getting up there. So getting up to 4,500 meters, and you can see here this nice big truck that was used to move the telescopes up to, I can't remember, the Atacama Desert effectively in Chile. And they're very huge, massive projects. So you can see they've cleared the road, they've made it quite flat. And this is the limitations. These are the limitations for what we can do on Kilimanjaro. Because you don't want to build this road. You don't want this road snaking its way up to the plateau. They're not attractive. They really aren't attractive. And you can see the profile here. So there are points where it's at 20 degrees, a 20-degree grade for a machine like this might be problematic, especially as it's getting up to high altitude. So we have to find another solution other than this. We either have to make the telescope smaller, so we do less impact, we don't have to do anything to the roads, the pathways, or we find another way to get up the mountain. The solution in the end was really quite simple, because I struggled for some time thinking, economic, how can you make money from a road? And things like this. And of course, a road affected the aesthetics, it affects the environment. I thought, how can I minimize the impact on this beautiful mountain? And the answer is quite simple. It was so trivial once I asked a question, and that was, what do they do in Europe? And the answer was, you build cable cars. So if you were to build a cable car system, you could actually use that system, at least once it's being built, to also move the equipment up the mountain for the telescope to be constructed up the mountain. Not at the peak, not even the cable car at the peak for that matter. But you could build this cable car towards Mwenzi Peak, where it would have a clear view of the saddle and the iconic Uhura Peak. Okay? So this suddenly became a totally different model, because I said in the beginning, you look for solutions, and some solutions have more cost. Well, this is very costly, of course. However, what you can say about a cable car, if you build it, and you build it well, you can make fortunes from it. You can generate serious amounts of income, and you can do something else. You can change the nature of tourism on Kilimanjaro. You can go from adventure tourism to adventure and leisure tourism. Leisure tourism is 10 times more valuable than adventure tourism. Adventure tourism is those people willing to live in a tent for 7 nights and then come back and stay in a bed and breakfast and go away. Leisure tourists want to stay in 5-star hotels, they want to have a beautiful restaurant with an amazing view, and they want to sit up there and have nightcaps while they see the hikers trying to summit. And that's what the difference is. So one will spend tens of dollars a night for their living quarters. The other will spend hundreds of dollars a night for a living quarter. And so you really are taking a it's probably $50 million a year or something like that. generated by the tourism industry, the adventure tourism, and you're going to multiply that by 10. So it's going to be $500 million annual direct investment just because of going to leisure tourism. More importantly, you have to look at the multiplier effect. The area around Kilimanjaro is a relatively underdeveloped region, and if you have to go to cable car, then you have to build more advanced hotels. Now you have a multiplier effect of probably 4 or 6. So your 500 million becomes 2 or 3 billion dollars annual in terms of the impact on the local economy and the economy of Tanzania. Now that's substantial. And if you start thinking about something of this nature, you start asking yourself that this is no longer a science project, it's now a Department of Tourism project. So now you've got two ministries, Ministry of Science, Ministry of Tourism, who should be working together to maximize the economic return from this simple little science project. Because make no mistake, the telescope's only going to cost 10 or 20 million dollars US. The cable car will cost 250 million. Hotels will cost who knows. So that was absolutely a game changer in our eyes when we thought about this project, because suddenly it became economical. It solved the number one issue that we had, economics. It minimized the environmental impact because we can minimize the amount of damage to the rainforest that we're trying to go over. We can use these cars to do game viewing while we're going over the rainforest. And lastly, if we low sling it, we have no aesthetic effect. And we can make it look cool, as you can see in these pictures here, so that people that do see it go, wow, that's cool. High tech and cool. High tech and cool is okay. Low tech and uncool, not okay in terms of aesthetics. So we solved all three problems with a relatively expensive solution, but one that basically drives the economics into another atmosphere, like above, like up into the stratosphere, literally. We're talking billions of dollars return rather than millions of dollars return. Other cool things that you can add to this, depending on where you build your cable car system, is you can actually put things in like a cliff elevator. So you could go up the cliff face of Mwenzi Peak to a higher level, and you have a much better view, and you could put in a funicular train to go up to where the telescope is, all sorts of things like this if you wanted to go to the Mwenzi Peak. But of course, that's getting a little exotic. But irrespective, if you build the cable car, wherever you build it, we can use it to get our equipment onto the saddle and therefore not impact the environment. And that was one of the big issues that we were suffering from. The fact that we're now talking cable cars and people are now investigating cable cars means that when it's built, it will affect the economy of Tanzania in a very big way. And that's a win. That's a win-win. So we get to do our astronomy, which leads to astrotourism, which can be all sorts of things. But the cable car could also give us these other new and very important tourism opportunities that are absolutely staggering. So this really was a cool solution. I must say I was very pleased, and myself and Noorali were very excited when we first thought of it. And of course, one that shouldn't forget the foreign direct investment straight from the astronomy. The telescope itself that we're talking about putting in place after we do site testing and demonstrate that this is a world-class site is probably only about 10 or 15 or 20 million dollars in total, the total cost to construct and build, erect, etc. But some of the telescopes, once you have infrastructure there, you can attract other infrastructure, other telescopes, if you choose. And that represents an enormous opportunity for foreign direct investment. So here you can see Mauna Kea with all the telescopes on its not on its peak, but certainly up on the plateau, and it's at about 4,300 meters. This site is 200 or 300 meters lower than the site we can get in Kilimanjaro. And they're now building a $1 billion telescope on the mountain, and that's because they have the infrastructure in place. They have high-speed internet. They have their services. They have the technical services that is in place in and around the mountain so that they can provide excellent services for a $1 billion telescope. So basically, even without the cable car, the astronomy itself has foreign direct investment in the form of we build the telescope. The telescope has to have a base station. So there's got to be something at the base of the cable car where the astronomers can, do some of their science and then go up to site if they want to do repairs or do some work on the telescope itself. So all of that stuff has to come, and we will be able to give high-speed internet access, etc. All of these things can occur. So that actually does one really cool thing. The more telescopes you build, the more prestigious it is. That means we're maximizing the prestige. The more students we can be trained on the mount because there's more telescopes. That means HCD is going up. There's more technology being transferred into Tanzania. And finally, we're getting foreign direct investment, which is a form of economic activity. So all of these things are important. And let me add lastly with regards to this. Each one of these telescopes, if it costs $10 million to build, it costs $1 million to operate. So that $1 billion telescope is going to cost $100 million a year to operate. Just to give you some idea, $100 million a year. That's already twice the amount of money you would get from adventure tourism. So, and of course, to build something like that, you have to have serious road infrastructure, and that I don't think I'd want to do because it affects the environmental impact. And so, yes, we get greater economic return, but we get a higher environmental impact measure. So the answer to that would probably, in my books, would be no. But we certainly could build infrared telescopes up there and things like this, which would, add to real value around the world and lead to higher prestige, more students, more technology transfer, and yes, foreign direct investment. So astronomy can make you money, just the astronomy.
So, so here's sort of this is basically my last slide. I have a few other slides I'll show up. I have a bit of time, so I think I'll show them. But you want to optimize. And as I said at the very beginning of my talk, you have the four pillars. So you have prestige, you have human capital development, tech transfer, and economic activity. Well, prestige is clearly you want to do good science. You want to publish results and hopefully win Nobel Prizes. That's really what you want. That's what prestige is. You want to be the biggest, you want to be the highest, you want to be the best. And those are the words you will hear around prestige. So if we build at 5150, we will be the highest observatory in the world, and you can brag about that. You can say this is the high observatory and it's in Africa. You take ownership, and it gives it value, and you publish papers, etc. And the telescope, even a small 15-meter telescope, will do great science. Hartrail is 26 meters, it's 60 years old, and it's still producing world-class science. And the funny part is, most South Africans don't have a clue that it does that. Most of the people that are really excited about Hartrail don't even work in South Africa. They're all over the world. They just know the work coming out of out of Hartrail is that valuable. And even as a single dish, we're still producing results that no one thought possible. In fact, I remember someone came to me in a meeting and said, "Gordon, you were vindicated." I go, "Vindicated?" And what they were talking about was I had shown that these sources were variable. And no one believed, even I did. I published a paper once in 92 or something like this that said that these certain types of sources were non-variable. Well, I found one source that was highly variable, and I published that. And then it took 10 years for people to believe that. And that's because at Hartrail, they discovered the first periodic methanol maser, which changed the field of maser astronomy. It was the first major discovery in, probably 30 years. So it really was a major discovery. It was either the largest or the second largest discovery since they first detected masers in the 1960s. All done on a 26-meter telescope by a young PhD student. So, you're not limited by the size of a telescope. You're limited by the size of your intelligence. So just remember that. That's prestige. Human capital development's obvious. You just look at the growth of these programs. I'm sitting talking to a group of young astronomers and students that want to be astronomers. And you're sitting in a room, and there's other rooms like this all over Africa. And the programs that DARA is financing and running, the SKA program and how it's developed a lot of astronomy coming out of South Africa and Southern Africa and the African partner countries in the project, the numbers went from, tens the first meeting to hundreds the last time I was at one. And that is carrying on. So that's the human capital development. That's a given. That we know that, and to make that stronger, to be honest with you, when you design a telescope, you would say, create positions at the observatory where people can touch the technology. That includes the astronomy, it includes the electronics, the engineering of the telescope. You want young students touching the technology, okay? So you've got to create positions that does that. And that's what maximizes the human capital development. The prestige, like I said, takes care of itself. The technology, well, that's different. We're going to use high-end technology. And then the benefit is we got world-class engineers who come in to build it, to design it, to develop it, and they stay and train future engineers in the country where they're building it. So that's three. Well, and of course, as I said, the final thing is the economic activity, the odd man out. And we constantly forget that. So if we build an eco-friendly cable car and telescope, that was the solution that we came up with, myself and Noorali. And it was well received by the science community and the tourism board in Tanzania. And we're waiting, we put all the documentation, as I said, and we're waiting for permissions to start testing. You get benefits, and the obvious benefit is you're rebranding Kilimanjaro, not as adventure tourism, but rather leisure tourism. Adventure tourism is me, I wanted to climb the mountain to take a look at the weather, and I did that, okay? But leisure tourism is a person that just wants to sit on their fat behind, go up a cable car and have a glass of wine and talk to his favorite person, girlfriend, propose to his wife, future wife, whatever. And then of course the other one was, demonstrating that Africa is high tech, not, this when I first started in this project, one of the biggest issues we fought was Afro-pessimism. People didn't believe that Africa was ready to host the World Cup of soccer. They didn't believe that Africa was ready to build the world's largest radio telescope. They didn't believe in any of that. And we were always asked the question, how do you fight Afro-pessimism? And the answer is quite simple. Be Afro-optimistic. Don't accept what they think you are. There's too many great minds. The sum total of intelligence sitting on this Zoom meeting right now in the building is greater than any of these other places. There's so many bright people that I've met across the continent, and the capabilities and the possibilities are endless. We get limited because we start believing the BS that they tell us. And if we believe that stuff, we're going nowhere. So you got a dream. Now, this may be the biggest dream I've ever come up with, and that's a lie. This is not the biggest dream. You don't even want to hear the biggest dream. I'm not going to tell you. You'll think I'm crazy. But Elon Musk would love to talk to me about it, but he's a funny man to talk to. Anyways, and no, I don't know him. So I'm not trying to drop names. So my point is, though, that these are the kind of things that will happen. And of course, that's what you want to do. So you want to look at a science project and say, well, what is the real benefit to the government of this country or the people who are financing it? And then try to tease all that out. But the most important thing to remember, once you've optimized the design of the telescope to get the highest amount of prestige and human capital development and technology transferred and economic return, you have to remind yourself every day that you have to optimize it. And that means once I build the telescope, I can't just look up at the sky and say, yes, I'm doing something and I don't care about the money anymore. You can't do that. You've got to have somebody thinking about the actual, how it affects the country, and always remind yourself. And by the way, astrotourism, as it's described, is not simply going to an observatory and looking through a telescope or buying a telescope. That isn't astrotourism. That's part of it. The real astrotourism is the fact that they build gas stations so that people can drive to the observatory to see it, because the gas station creates jobs for locals. Okay, that's part of astrotourism. If you and I want to show some examples. Let me go through this. I got a bit of time, so let me do this. So that's me, by the way. Here I am with my daughter. We're on top of Kilimanjaro. This is 2012. We climbed up there. And I'll tell you something for nothing. It's not hard to climb. It's just tiring. It's really tiring. In fact, it's 12 midnight. We started walking at midnight, and it took us 7 hours to get to this spot. And it was just tiring. It was annoying. That was my description of it, annoying. but absolutely spectacular views, absolutely spectacular views. And anyone that I'm talking to right now, if you can do it, do it. It's worth it. It's just beautiful. You can see the night sky here, and that's what I saw when I was up there. The night sky was amazing, and I could see moisture, coming right out of the air. It was like clear air, but there was moisture freezing out of it, precipitating out of the clear night sky. So the moisture was actually falling to the ground as snow effectively. Okay, but that's not good for astronomy. But you can't have everything. So what I want to talk about though is something as simple as this. The World Cup of Soccer in 2010 is really what helped all of us do our astronomy today. If it wasn't for the World Cup of Soccer, none of us would be sitting here today having this meeting. I'm telling you, I'm not joking. I don't, well, let me correct that. It would not have been as big as it's becoming, okay? And why I say that is the World Cup of Soccer did something absolutely amazing. It built its biggest value add to Africa was the high-speed internet it gave us. They had to build high-speed internet cables, submarine cables, around the continent, around the coast of Africa. And as a result, they were able to give high-speed internet to the continent, which meant that I can talk to you on Zoom as if I'm in the room with you. Okay? So the real value of the World Cup of Soccer was not the games. It wasn't the stadiums they built in South Africa. It wasn't the improvement in the roads, which really helped a lot to the South African economy. But to the continent of Africa, the value of the World Cup of Soccer was, one, it proved we can do it, and two, it gave us high-speed internet. And those are two things everybody in this room should always remember. You can do it, and you can get what you can do from it. Okay, so that's the World Cup of Soccer. That was sports. Sports led to the development of a lot of science programs. Sports ensured that we would win the World Cup, the bid for the SKA, which is in effect the World Cup of Astronomy. So Hart Rail, as I said, 61 years old. Its value is not the astronomy that I'm talking about. It's not that young woman that did her PhD on periodic methanol masers. That's not what gave this thing value. Hart Rail is involved is one of the 4 only fiducial points in the world where they do VLBI, GNSS, SLR, that's satellite laser ranging, and DORS, which is a radar-based GPS system. And all of that contributes to the accuracy of the GPS on the continent of Africa. So if you don't have Hart Rail, you get like a 10 or 20% degradation of your GPS network. So if you're trying to follow the map to get to your hotel, it's going to be out by 100 meters when it says to turn right, right? So the value of Hart Rail is the effect it has on the entire world's GPS networks. And that's a fact. At Hart Rail right now, there is a Russian and an American satellite laser ranging system. The Chinese are going to build one there. So there'll be 3 satellite laser ranging systems there. There's VLBI. Anyways, they go on. That's the value of Hart Rail. Hart Rail, its value is not astronomy. It's not astronomy. It's the geodetic programs that it's been involved in since the 80s. That's led to its value add to the continent and the country of South Africa. And certainly not the science I produced there. And I published a fair number of papers from that telescope, and I do to this day. I still use that telescope. It's my baby. Okay, so that's Hart Rail. The AVN is the one that we've all talked about. I heard the other day when I was giving a talk that people say, the Ghana experience was problematic and people don't want to do converting antennas. I understand. I would rather build a brand new telescope from scratch because I get everything I want as I designed it. If I want to optimize the economic potential of a project, I want to have my hands in the design of the telescope. And you don't get that from a rebuild. But at the same time, it's still an exceptional facility. Okay. And in this case, it improves the interrelationships between African countries. So the problem one of the problems I saw in Africa, it's my experience, so just my humble opinion, don't take it for anything more. But a lot of the countries, they didn't allow you to fly direct. So there's an island off the coast of Nigeria. You got to fly to Europe to get to it. Well, anyway, it's just crazy. That drove me crazy. So that's an example of that. So again, it's the improvement of communications. Yeah. Am I out of time?
Yeah, you are running the time, but out of the time, but you can just summarize and
okay. Well, I have summarized, to be honest with you. So what I want to say, and the last one I want to mention, just the SKA. The SKA is not astronomy also. It's supercomputing. It's cloud computing. It's $1 trillion industry. That Southern Africa will dominate that industry if they build the SK there. And they should build it. I told South Africa to build it themselves, pay for it themselves. So when I finish here, what I'm saying is we're ready to do site testing on Kilimanjaro, but the reality is this project is going to benefit. It's going to benefit the economy of Tanzania more so than just the astronomy. So understand this: when you look at a big telescope, there's economics involved, and there's money being made by someone. And it's just the way it is. So let me finish there and just say that. So all of you who are listening, just go out and enjoy yourselves and keep looking, keep imagining, because that's what gets you where you are. Thank you.
Oh, fantastic. Oh, so thank you very much, Gordon. It's really, the talk is very relevant to our situations, and these aspects of economics, people ignore them. And these projects, which are very big, it's very important that we know all these aspects. So let me see if there are questions really. I see an interesting. What about the power supply for cable car? Can you check on the chart, Gordon? Are we able to check on the chart?
I'm trying to see. Let me just see one second. I should be able to. Where's it say chat? I'd have to stop sharing my screen, I think, which is fine. No, is that right?
No, you can continue.
No, it's okay. No, we're okay. We're okay. I gotta put my glasses on. Sorry, I'm blind.
Okay, so I can just read for you.
There's excellent examples of cable car. Hold on, there are excellent examples of cable car systems. Some observatories in France, Switzerland. Absolutely correct. I was at Grenoble for a while working, and I went up the cable car there to Pico de Boer. Absolutely right. Sorry, go on. There's more messages. Let me carry on down. They seem to say, okay, interesting. What about the power supply, the cable car, and the facilities? Exactly. That's a very good question. In the area that we're talking about here, you'd probably want to go off-grid systems. You can do solar. I mean, it is a fairly good environment because it is it's very arid in some places, but I don't trust solar because you get clouds, you got no power. So it's one of those things. So we'd have to try to build something. Let me think about that. I'd have to look at I've done alternative energy in a lot of areas. So you could build a combination of solar thermal and stuff like that, but you need a base load, and it's even a small telescope. The cable car itself will run probably 30 megawatts. The telescope will run another 20, 30 megawatts. It'll be 50 megawatts. The real problem is you have to build lots of hotels, and they'll take up more power than your telescope or cable car. So this is a really good question. This is an important issue because how reliable is the network? I have a question. See you out. Sorry, I'm going to go on. Very interesting, Gordon. Thank you. Okay, that's not going to help us. Yeah. So yeah, the power is an issue. So that's a good question. I would say to you that you probably can build off-grid systems. You can. I don't think there's any natural gas in the area, so that's a no-no. If there's hot springs, there's probably natural gas, but you'd have to really search for that. That's a no-no. You could use thermal, maybe. It is a volcano, remember. It's a dormant volcano. So it is possible, something like that.
Yeah, thank you, Gordon. I asked the question, so now I put the video. Yeah, well, actually, in Africa right now, there are many off-grid power systems with powered by solar plus batteries. So and those work. There are many examples now. No? The issue is that it's a lot of power that you need. So it's really very big.
Danielle, you're absolutely correct. I designed some grid systems for the Congo. I was in the Congo during the last Ebola outbreak. That was my last project I worked on. And we had to build not only a solar park, we had to build the power station, the ring, the power ring, to drive the power to the sites and then give last mile connectivity to the mines. So it's the same idea. Absolutely can work, especially with the work that guys like Tesla is doing.
Gordon.
Yes.
There is a lot of noise. We can ask IT people to mute. Somebody called
It's from
Alan.
Alan Muhammad. Mute.
Please mute Alan.
But I want to summarize that last answer though. I would try to build solar. I agree with you. You're at the equator. There's lots of sun. Okay, it's muted.
You can go on, Gordon.
Okay, if everybody can hear me, I just want to summarize. I was asked if we could use off-grid systems, and Danielle is absolutely correct. There are some very good systems that would work for that, and it works all the time. I would probably build a diesel. I would have a combination of things: battery, solar, and I build a diesel farm as well. That's how I'd run it. You need to have a backup base load. You have to, because everything goes up and down. And the batteries themselves are not 100% all the time too. So the batteries are getting better, but they're still not. That's our biggest weakness. That's the biggest cost, actually. You don't want batteries; they're expensive. So
yeah, this is the standard solution to have a diesel backup in off-grid systems. Yeah, that's right.
Yeah, absolutely. Yeah, I agree with you. So that's what I would do as well. That was what we designed for the Congo in a project there. So, and one of the projects I was involved there was actually hydroelectric. They were talking about the Grandinga. That was pretty amazing too, I must tell you.
Gordon, there is a good question which is being asked. When we talk about astrotourism and you take visitors with no cell phones, with no cell phones, how will it work?
Oh, no. You're absolutely right there. Remember, radio astronomy is a lower frequency than the frequencies we're talking about. I would not build a telescope at 5,000 plus meters to do radio astronomy. I would build it to do millimeter only. And so the frequency is much higher than the radio interference you're going to get. So cell phones would not be a problem.
Okay.
Right. So, and you remember, I mean, at Hart Trail, there's a law in and around Hart Trail, the telescope, you can't have a microwave oven. That's true at most radio telescopes because microwave ovens produce radio interference at 18 centimeters, which is a very important line in astronomy. So, I mean, this is a very good question. Absolutely correct. No, if I was building telescopes on Kilimanjaro, I'd be talking about millimeter infrared optical. I would probably stay away from the radio. The problem with the SKA is precisely that. They're building the SKA, but in order for it to function properly, you can't have people living there. So you're telling people to move away. So you're running off the farmers. Well, that's not good for economic growth. So that's a weakness of the SKA, in fact. There's a whole bunch of weaknesses. I could talk forever. So yeah, no, that's a good question. But no, we're going to stay at higher frequencies, away from the bands that they use for this. And one last thing about this too, by the way, this is interesting as well, that they're moving away from radio, from radio. They're starting to go towards laser-based communication systems because they have higher bandwidth. They can carry more data. And if that occurs, then the radio astronomy will become less of a problem as well.
I have a question also.
Okay.
Thanks for the presentation. That was really great. So the two things, I mean, the cable car definitely needs one point is the maintenance.
IT people, somebody.
Alan, yeah, Alan, can you please?
Sorry. I would like to just comment very good presentation from the presenter, and actually we have that dream to launch this a telescope on the Mount Kilimanjaro. But I hope the logistics may be underway, maybe the discussions with the ministry and so. And we believe once we succeed, we are going to rebrand the Mount Kilimanjaro and attract many tourists and even scientific community who would want to observe the African sky. So I just wanted to congratulate the presenter.
Okay, thank you. But you were not given the floor. The floor was for Miliana. Sorry. Okay, right, but good information.
But I heard that I was mentioned. I'm sorry.
Oh, okay.
All right.
Okay.
Yeah, no problems at all. So I was asking Gordon about the maintenance of the cable car because it will need much more continuous maintenance, much more than if you just build the road. I mean, I agree fully that the road is not
Absolutely.
the option because we are losing rainforests, primary forests, so we cannot, even if you have to cut one single tree, for me, it's really not a solution. So, but I mean, in terms of the long-term planning and maintenance and funding for that, because you don't want something to happen like it happened in France with Iram, no? That you have,
Yes.
the big accident, and then you have to, people don't want to use cable car
Yep.
anymore, and so on. So that's
Yep.
one point to think about, and another point to think about is really the conservation of the site. Because you mentioned that the rainforest is currently preserved, but not the top of the mountain.
Yes.
So I think if we really speak about once you put the cable car, that opens, as you said, many possibilities, for the development of the economy and so on. But it can also affect, the in future with
Yep.
the whole development that we are talking about. So I fully believe in, that if we want to preserve a specific site for the scientific development and and infrastructure development in science, it's important to conserve the site. So these are 2 points that I don't know if you can comment a bit more at this point.
Yes.
Yeah,
I can. I
thank you.
can. Thank you. Those are both very good questions. And the maintenance side is surprisingly, I'm going to say easy, and I don't want to sound flippant about it. But the reason I say that is when you read, if we were building like Pico de Boer, it's basically for the astronomers. So it's a science budget operating cost, and it can become hefty. You're only using it to carry people up the mountain, to do astronomy, and so that's quite expensive. Whereas if you're doing tourism, it's part of the budget, it's part of the cost of the ticket. So I mean, I'm selling tickets. I'm saying it's going to cost you $50 to go up the telescope, and I mean, for Europeans to fly in, they're going to be charged. You're going to give different rates for the locals. You're going to say Tanzanians will get it in Tanzanian dollars, but the Europeans and the Americans, et cetera, are going to be charged $50, whatever it is. And the maintenance cost will be built into that. That's how you do it. You design your financing. It's a business model that has to be sound. It's got to be economically sound. It was the first question I wrote as one of my issues. So the maintenance I don't see as much of a problem. The interesting part is getting water up the mountain and waste down the mountain, and it leads to what your second point is. So you would build a special car that would replenish all the resources on the mountain. There's no water on the peak of Kilimanjaro, surprisingly. You're not going to take the glacial ice and melt it and put it in your tanks. Someone would shoot me, and I would shoot myself if I suggested that. So I
Many
can promise you, I know
astronomers.
you would. You're right. Not doing that. We're not doing that. The same as Pico de Boer, you take it up in a special car that takes the water and then takes the waste down. So that's how you would do that part. The second thing, interestingly, is that because you're going to 5,000 plus meters, you cannot have people go outdoors. So these people that are going to travel up the mountain are going to be in pressurized observatories, observation decks. They're not going to go outside. It's just too dangerous. I mean, you'd have to have oxygen with them and stuff like that. So that actually means that the tourism that I'm talking about will not lead to excessive amounts of any kinds of waste on the mountain. It's going to be fully contained and controlled inside buildings. And even the cable cars themselves have to be pressurized from the midpoint upwards. So you would build less expensive cars to the midpoint, and then in the midpoint they would transfer to pressurized vehicles to the top. And you'd have to have medical staff at site as well. I mean, I climbed the mountain. It's, if you're not used to altitude, which I am, I like being on top of mountains. I've almost been blown off too, by the way, which is because I'm stupid. I do dumb things. But anyways, I shouldn't say that. Then people don't believe my talk. But the point I'm saying is, though, the maintenance is one. The environment is very dangerous. I was up there when I climbed. It was horrible. I went for a walk by myself in the evening when everybody else was in their tents resting, and I wandered around into the back bushes and the woods, and I saw things that I got to tell you, it was horrifying. It was just horrifying, and it needs to be cleaned. It needs to be cleaned up. And that's an environmental destruction at a scale. And that's just from the people who climb the mountain. Okay. Now it wasn't, I don't mean, I shouldn't say horrible. I mean it differently. They like refuse lying around, toilet paper floating on trees and stuff. It, looked terrible. And that you'd want to clean up, obviously. And that's the kind of thing that you don't want to have. You want to avoid that. And so we would do that by ensuring that people are in pressurized rooms so they don't get sick. And two, we can control where they are. And in light of this pandemic, you can understand we would have to even think about how we would do that as well. So even the ventilation systems and things like that, we would have to really seriously consider, because future pandemics I'm hoping we don't see another thing like this in my lifetime, but I'm sure we might. So that's a very good question, and it's a point that we keep it in our head all the time, because the ecology is important, and including the peak. Where you see where I'm standing there on the peak, and that's at 5895, and you can see the frost and whatnot, and you can see the glaciers off to the one direction and stuff like this. You don't want to pollute that, And I got to tell you something. The easiest way to protect an environment is to never tell people about it.
Yes,
That,
I mean,
Gordon, I think you have to stop.
yeah.
Okay, sorry. Sorry.
On the large scale, I was thinking conserving the area. So coming up with the government to extend the conservation of the whole areas in future, because once you put the cable car, that will bring many people. And I mean, that will open possibilities for the investment as well. You cannot guarantee that somebody will not put the hotel, beside the observatory, for hosting, tourism.
I've had people ask me exactly that question. I said
So,
no. They
and
said,
then that maybe for
dangerous.
future investments, the rainforest
I
can
know.
also be destroyed, putting the road and so on, even if.
I agree with you. I agree.
Conserving the area is something really to work with the local, with the Tanzanian people, no, and see what are the, so that on the long term we make sure that that it will not be destroyed, the site.
I will end with one point, and it's to that. And the one thing I've learned in this world is no matter what we think we should be doing, you're absolutely right. What may happen later is, and that is the point. I mean, and there's nothing I can tell you right now, I've already said that somebody took this project and they're now running with it, and we're just waiting for them to build a cable car to start building. So we don't have control over that. What we do say is, if you do build it, you're going to kill people if you don't do it right. And that's even worse. And so in fact, I want that to scare people so they don't do those things that you're talking about. I don't want a hotel up there. It'd look terrible. It ruins number 2, aesthetics, or that's number 3.
But
you're absolutely correct.
Conservation is extremely important.
No, I understand that, but in the end, that's what the genie's out of the bottle. But thank you. Sorry.
Thank you very much. I think, it's a disaster now in terms of time. So
I'm sorry. I'm very sorry.
No, I'm very, very, very excited. I think also I feel many other people also are excited to hear this story of Tanzania, because nobody was thinking that there is such development in terms of study of the implementation of this telescope. So we cheated on time, but for the good, for the East African community to hear about the whole story of this Kilimanjaro telescope. Hope people will bear with us when we will need to borrow some minutes from other presenters. So now, what maybe I will suggest is that Tanzania also should be growing in capacity building, just developing scientists and engineers who will drive this telescope. So anyway.
The JIRA Foundation will produce more videos like this. Please like, share, or subscribe if you enjoyed this video.